This video is going to be on logical volume management. With this, we'll be able to create logical volumes, which are partitions in a way that you can actually resize on the fly while users are still connected. We're going to talk about how to create the logical volumes, how to resize logical volumes, and how to view your logical volumes. So first, before we start, let's go ahead and create some extra hard drives so we can use, or add some more hard drives. Now, you could use one hard drive, but it's recommended to use multiple hard drives since you are able to combine the storage of multiple hard drives as if they were one drive. So let's go ahead and just press Settings. And I'm going to go to System, Storage, and then under the SATA controller, we're going to go ahead and press Add Attachment, Add Hard Disk, and create new disk. We'll use the default, dynamically allocated, and we'll leave it as new hard disk 1. Let's give it 20 gigabytes. Create. Let's go ahead and create two more. New hard disk 2. Now, the drives do not need to be the same size, so we can actually, let's make that one 16 gigabytes. And let's add one more hard disk. With 3. And we'll leave that one as 8 gigabytes. So now we have a 20 gigabyte, a 16 gigabyte, and a 8 gigabyte drive that we can use, as well as space from the first drive that we set up. So let's go ahead and press OK, and we're going to start our machine. Now that we have our system up and running, let's go ahead and log in. Give it a second. And the first thing we're going to want to do now is open up a terminal. And let's log in as root. I'm going to zoom in a little bit. Alright, so now that we're logged in as root, we're going to want to type in the fdisk utility -L to list out the available drives. So you'll see that we have 4 drives now in total. Our SDA1, which currently has a partition table. Our SDA2, or our SDB I mean, which does not have a partition table. Our SDC, which does not contain a valid partition table. And our SDD, which also does not contain a valid partition table. Now, if you recall, we had our SDB, which had allowed 20 gigabytes of space, our SDC, which had 16, and our SDD, which had 8. Now, you'll see that the numbers are never accurate exactly, but that's okay. Let's go ahead and type fdisk /dev SDB. Now we're going to create one partition for 20 gigs on that one drive. Let's type N for new, P for primary, partition 1. We'll start it at the default first cylinder, and we'll give it 20 gigabytes. Values out of range, since I guess we don't have the 20 to use on this drive, we'll just do plus 18 gigabytes, and let's write our changes. So now we have one part. Well, let's type fdisk-L, and you'll see that we now have SDB with an 18 gigabyte partition. Let's go ahead and create some partitions also on the SDC and SDD. So we're going to do fdisk and the path at SDC, N for new, P for primary, let's use the default, and we'll do on this one 15 gigabytes. Let's write it, and let's do the same for the last one. STD, new, one partition, and we'll do 7 gigabytes. Oops, sorry. P for primary, partition number 1, and 7, the first cylinder 1, expand to 7 gigabytes. Let's write it, and now if we do fdisk-l, you'll see that now each of our drives has a valid partition scheme. One thing though, in order to use these partitions under logical volumes, we'd want to change the system type to be Linux LVM. So let's go ahead and log back into fdisk, dev sdb, and if we do M for help, you'll see that the T option, the T flag, will allow us to change the partition system ID. So if we type T, we can use L to list out the codes, and what we need is 8E for LVM. So by typing 8E and then print out the partition table, you'll see that that partition will now be Linux LVM after we write the changes. So let's type W. If we do fdisk-l again, you'll see that that one is now Linux LVM. So let's do the same for the other two. And we're going to do T for type, 8E for Linux LVM. We'll print it out to verify and then write our changes. And let's do the same for STD. We'll do T for type, 8E, and we'll write our let's verify and then write our changes. So now if we do fdisk-l, you'll see that all of our three drives all of our three partitions are now of type Linux LVM 8E. So now that we have the partition set up, let's go ahead and use the utility called pvcreate, physical volume create. Now what this will do is it will allow us to allow the logical volume utilities to know that we can use these partitions for logical volumes. And we do that by using the utility pvcreate followed by the pass to the partitions. So we have dev sdb1 space dev sdc1 and space dev sdd1. When we press enter, you'll see that it successfully adds the three partitions as physical volumes, usable by logical volumes. After we create our physical volumes, we need to create a volume group. So to create a volume group, we need to do vg create, then we're going to do space, the name we want to give it. So let's say we wanted to give it volume group 1. And then we'd do space followed by the partitions that we added to pvcreate, or the partitions that we want to use for this volume group. So in that case it would be dev sdb1 space dev sdc1 space dev sdd1. We're going to press enter, and you'll see it goes through and creates the volume group for vol group 1. So after we have our volume group, we can actually use VG display to list it out. And you see we have one volume group that is resizable with a volume group size of 40 gigabytes. Now if you remember, we had three different partitions and not one of them were 40 gigabytes in total. But with logical volumes we can actually combine multiple partitions, so we can use it as one drive for anything we want. So we can actually make larger drives or drives that we currently have and combine them. So let's say we only had 2 gigabytes on each thing, on each partition or each drive, we can actually combine those to make one logical volume or one drive. There's also another utility to see the physical volumes, PV display, which will show you the physical volumes that are usable by volume groups. So here you see that dev SDB1 is a part of the volume group vol group 1 with a physical volume size of 18.01 gigabytes. So the next utility, after we have our group, we actually need to create our logical volumes. So in order to create a logical volume, we use the utility called LV create, followed by the -L flag, which will allow us to determine the size of the logical volume. So let's say we wanted this drive to only have 5 gigabytes. So we do 5G, and we'd follow it by a space N, which would allow us to actually give a name to the logical volume. So let's say we want it to be log, and we'll just call it logical volume 1. And we're going to give it, and then we'll do a space after that, and we define the volume group that it belongs to. So we do vol group 1. So here what we're doing is we're creating a logical volume of 5 gigabytes. We're naming it log vol 1, and we're applying it to the volume group 1. Since you can have multiple volume groups on a system, you need this in order to define which group the logical volume should belong to. So let's press enter. And you see that the logical volume log vol 1 was created successfully. To view it, you could also use the LV display utility, which will then show you the logical volumes on your system. So we have del vol group log vol 1. So now that we have that, let's go ahead and pwd. So right now we're in our home directory, and let's just create a folder within our home directory, and we'll call it makedir. We'll just call it logical volume 1. Keep it simple enough. So now you see we have an LV1 folder, logical volume 1 folder. The first thing we're going to want to do is format the logical volume that we have just created. That way we can mount it to our mount point. So let's go ahead and do mkfs. We'll do .ext3. So we'll make it ext3 format to the dev vol group 1 log vol 1. Press enter. You'll see that it successfully formatted that partition. It's creating the journal, writing the superblocks and the file system information, and it just lets you know that the file system will be automatically checked every 25 mounts or 180 days, whichever comes first. So now that we've successfully partitioned that, or added our partition scheme to that partition, we can now mount that to, using the mount utility, the path to the logical volume. So vol group 1, log vol 1, and then followed by the mount point. In this case would be root LV1. We press enter, and if we do df-h, you'll see that we now have a new mounted partition, or mounted logical volume, to our defined mount point of root LV1. Another thing you can do is rename the logical volumes using a utility of LV rename. So in order to do that, we would do LV rename. Well, first we'd want to unmount the mount point. So we'll do umount root LV1. So if we do df-h, you should see that we no longer have that logical volume mounted. So now to rename it, we would just do LV rename. We need to define the volume group. So that was vol group 1. And then we need to define the original logical volume name, which was log vol 1. And we want to rename it to the new name that we would like, which would be log vol 1, and we'll just say renamed. We press enter, and you'll see that it was renamed successfully. So now when we go ahead and try to mount it, we need to define the path, dev vol group 1, and it is now called log vol 1 renamed. And we're going to go ahead and mount that to our root LV1 directory. So if we do df-h, you'll see that it is now mounted to the root LV1 directory with the new renamed logical volume name. Now you can also delete logical volumes by using the LV remove utility. So let's go ahead and unmount this drive. So we'll do umount root LV1, and we're going to do LV remove, and we supply the path of dev vol group 1 log vol 1 renamed. It asks you, do you really want to remove the active logical volume rename? Just press Y for yes, press enter, and it'll let you know that the logical volume of log vol 1 renamed was successfully removed. So if we do LV display, you'll see that no logical volumes display. So let's go ahead and recreate a logical volume using LV create -L. We'll give it a 10 gigabyte of space this time. Or let's give 5 gigabytes, and then we'll talk about how to resize it to 10 after. Do -N. And now we just need to do vol group 1. So we're defining the group that sorry about that. After the -N flag, we need to supply the name that we want to name it. So we'll just call this log vol 1. And then after that, you define the group of which this volume should belong, which is vol group 1. So the LV create utility will allow us to create the logical volume. The -L followed by the size will allow us to determine what size the logical volume should be. The -N will allow us to name the logical volume. And the last parameter is the group of which this log vol 1 should belong to. Let's press enter. And you'll see that log vol 1 was successfully created. So if we do LV display, you'll see that we now have the 5 gigabyte logical volume available to us. So now let's go ahead and mount that. Mount dev vol group 1 log vol 1 to root LV1. Oh, before we did that, we forgot to actually format it. So mkfs.ext3 dev vol group 1 log vol 1. Press enter. Let it write all the changes. Then we're going to try to mount it again. And you'll see now that it was successfully mounted to the root LV1 folder. So now we have 5 gigabytes of space available to that folder. Now this is where the beauty of LVM comes to play. We can actually resize the folder on the fly. So in order to do that, we need to use the utility LV resize. So we're going to go ahead and do LV resize -L to determine the size, and we want it to be, let's just make it 10 gigabytes. And then after that, after the size, we just need to supply the path to it. So we do dev vol group 1 log vol 1, and we press enter, and you'll see that the logical volume was successfully resized, extending the size to 10 gigabytes. So we just added 5 extra gigabytes to that space. Now we'll just do LV display to confirm the size. So you see that it's now 10 gigabytes. And if we do df-h, you'll see that the size still states as 5 gigabytes. Now that's because we still need to run one more utility, which is the resize to fs. And this will allow us to actually set the resize. Well, let's look at the man pages. It'll allow the system to know that the drive is now resized, to reread it pretty much. So we'll do man resize to fs. And you'll see that resize to fs is for ext2, ext3, and ext4 type file systems. This will resize the ext2, ext3, or ext4 file systems, can be used to enlarge, shrink, an unmounted file system. So let's go ahead and press Q. So notice that it did say we have to unmount it. So let's go ahead and do umount root lv1. And now let's run the utility resize to fs. We're going to use the -f flag and the -p flag to give it the path. And let's say it is dev vol group 1 log vol 1. You'll see that it's resizing the file system. And now we can remount it using mount dev vol group 1 log vol 1 to root lv1. If we do fdist-l, or not fdist-l, sorry, df-h, you'll see that it is now 9.9, roughly 10 gigabytes resized.